Hello all, this video is on interfacing 8051 with the GSM to send SMS. We'll be using SIM 800A GSM in this project. The first part of the video is on initialization the serial port and the registers and timers. You can watch the first part and then continue with this. The project board has got inbuilt MAX232 IC and RS232 connector, and the GSM board has also got a DB9 connector. So you can use a DB9 male to male cable like this to connect the DB9 of project board with that of the GSM board. The inbuilt MAX232 IC converts the TTL level to RS232 level, and again at GSM it is converted back to TTL level. You can also use the TTL pins P3.0, which is the RX pin, and P3.1, which is the TX pin of 8051, to connect with that of the GSM. On GSM also the TTL pins are available, ground, TX and RX. You have to connect TX to RX and RX to TX, reverse connection. So either way you can use either the DB9 connector or the TTL level directly. There are many types of boards available in the market. This is the SIM 800A GSM board with the inbuilt 5V regulator. On the back side you have got a SIM holder where you can insert a valid SIM. The other type is SIM 800C, which is of compact size. All these modules are SIMCOM modules and quad band modules. All boards have RS232 IC on board, and on the back side there is a SIM holder. And the next board is SIM 900A. So this is obsolete now and a bit difficult to get now. So we'll be using SIM 800A in this project. SIM 800C is compact size and has got FM and Bluetooth also. SIM 800A is quad band and it has got better signal reception. So we'll be using the TTL connection for connecting with GSM. For programming we need USB ASP or AVR diode. Let us use a valid SIM. Any 3G 4G SIM will work on this GSM board. Only the LTE 4G LTE SIMs like JIO will not work with this board. 2G 3G or even 4G also will work, but LTE SIMs will not work. Place the SIM on the holder and slide lock it. You need a 12V 1A, at least 12V 1A adapter for powering up this GSM board. Provide the power to the GSM board and watch the signal LED. It initially blinks fast, that is once per second. It means searching for network. And once it receives the network, it blinks once per 3 seconds. The blinking will go slow. That means it has got a network and the GSM board is ready for operation. And there is a stub antenna for the reception of the signal. So the first step is to call to this number to verify that this SIM is working, the GSM is working. Now let us connect the AVR diode, that is a USB ASP, to the project board. Take care to connect the ground pin to ground. It should not be reverse. And the other end of the AVR diode should go to the PC. That is, the USB cable is connected to the PC, and you should have installed the USB ASP driver for this. So no separate power source is required for the project board. Only power source is required for GSM board. Now let us connect P3.0, which is the RX pin, P3.1 is the TX pin, and ground pin. We'll be using female to female jumper wires. This P3.0 RX will go to TX of GSM. There are 3 pins separately taken out of the GSM board, connected to TX of GSM, and P3.1, which is the TX pin of 805, it goes to RX of GSM and ground to ground. Any one method you can use, either the DB9 connector using the male to male DB9 cable, or directly the TTL pins P3.0 and 3.1 to GSM TX RX pins. Now let us see how to use the AT commands with the GSM board. The GSM board is controlled using AT commands. For this testing, you need a RS232 to USB cable like this. If you do not have this cable, you can just skip on this portion of AT commands. This is just for understanding the AT commands. Connect one end of the cable RS232 to GSM board and other end to one USB port of PC. Now open the device manager, and under ports you can see the COM port allotted. For this you should have installed the driver. The driver required for this cable is CS340, as it is built on CS340 IC. We'll be using PuTTY terminal. This is a serial terminal to test the AT commands. Download and install it. Open the PuTTY serial terminal, select serial and then the COM port 3. Speed is 9600 baud and click on open. You will get a black window. If you type in AT, the GSM will respond with OK. Next command AT plus CGMM will return the type of module we are using. We are using SIM 800A, and the next one is AT plus C pin and a question mark. This inquiry means you use a question mark. It will say the SIM is ready. If any problem with the SIM, it will give the problem code. Next is the ATE0. That is the echo off. Normally it is on. Now let us make it off. ATE0 echo off means whatever you type you will not see on the screen. So again we'll make it ATE1. Now if you type AT, you can see the commands. So this is echo on off. To dial a number, we use the command ATD followed by the number and then a semicolon. The semicolon is a must, and you get a call on the number. To hang the call, ATH, and to attend the call, ATA. To send SMS, first you have to make the GSM to text mode. For this we use AT plus CMGF equal to 1, and then we use the command AT plus CMGS equal to, and open the double quotes and give the phone number to send SMS and close the double quotes, and after enter you get a greater than symbol. Now you give the message to send, and then finally press the Ctrl Z. This is very important. Only if you press the Ctrl Z, you will get the message on the phone. And the next one is the baud rate. For this command is AT plus IPR and a question mark. It will return 0, which means it is in auto baud mode. To know the types of bauds available, AT plus IPR equal to question mark will return all the types of bauds supported. Initial it is 0, which means it is in auto baud. Whenever you connect 8051, it will automatically adjust to the 8051 baud. But for safety, we will use AT plus IPR command and then equal to 9600, so that the baud rate is set to 9600. So from auto baud we will set it to 9600. Now remove this cable and then connect the USB ASP to the PC's USB port. The USB ASP driver should have been installed previously. Now open the Kale microvision. To start the project, create a folder for this project and then click on project, new microvision project, and browse to the location of the project folder. Provide a name to the project and then click on OK. Next select the ICS 8089S52. The project is created. Right click on target and select and feed in the crystal value as 11.0592, and click on output tab and select the create output, create hex file. Right click on source group and select the C file. Provide a name to the C file and then click on add. Now under the editor window you can type in the C code. Start with, we include the header file reg52.h. This is to make the compiler understand the ports of 8051 and registers. Next comes the void main function. This is the main function from where the code will start. Inside this main function is the while one never-ending loop, and from within the main function we make a call to 3 functions. First function is UART underscore init. This is to initialize the serial port of 8051, and then we give the function declaration before the void main. to any functions we use, we have to declare it initially before the void main. So before void main, we give void UART underscore init. Next function is GSM underscore init. This is to initialize the GSM SIM 800A. So we give the function declaration void GSM underscore init. And the third function we call from void main is send SMS. This is to send the SMS. Send AT commands to GSM to send the SMS. For this also we'll give the function declaration void send SMS. And we need a delay function. For delay function we'll provide the function declaration void delay, and this delay function takes a parameter item. Let us give the variable name as item, and it is of type unsigned integer, unsigned int item. So int is 2 bytes, 16 bits. If we use char variable, that is only 1 byte. So we use int for the delay, and this is the delay function. Inside the delay function we use 2 more variables, integer variables, and nested for loop. Notice that the first for loop doesn't have a semicolon, and the second for loop has a semicolon. This generates 1 millisecond delay, and we pass on the parameter item to generate the delay. Now let us see the serial initialization void UART underscore init. This is the serial port initialization. You can watch our first part of this video to understand this. SCON is loaded with 0x50. This will make the serial mode as 1, and TMOD is loaded with 0x20. This will make timer 1 mode 2 8-bit, and TH1 register is loaded with 0xFT. This will generate baud rate of 9600, and then we switch on the timer using TR1 equal to 1. And the next function is to initialize the GSM void GSM underscore init, and inside the braces we'll use a function send underscore str. This is a send string function. For this code we'll write after this. First command we have to send under the double quotes is ATE0. This is to make the echo off. And the next is we need a carriage return. For carriage return we use the ASCII code 0x0d. Send underscore chr. We use the function send underscore chr, which is to send a single byte, and we send the ASCII value for carriage return 0x0d. After that we include a small delay of 200 or 300 milliseconds. This delay is very important. Do not omit this delay. So for sending AT commands we need delay. Now let us do the function declaration for the 2 more functions we are going to write. Void send underscore str. This is to send the string, and it takes a variable unsigned char. We use the pointer variable asterisk str. For the str memory location we use the asterisk symbol for pointer variable. And next is the void send underscore chr, and it takes a parameter unsigned char chr. This to send individual bytes, and the number to send we store it inside unsigned char, and pointer memory variable number asterisk number. We'll let us store the 10-digit number. We can use the country code or not. And before writing the function for this send underscore str and send underscore chr, let us complete the GSM underscore init function. First command we have sent already ATE0. Now let us set the baud rate. Send underscore str between double quotes AT plus IPR equal to 9600, and then we send 0x0d for the carriage return, and then a delay. And the third command we'll send just AT. This is just to make sure the GSM is ready, and then a delay. So this is GSM initialization. Next we'll see the that is the send underscore char, send character, that is the individual bytes. It takes parameter unsigned char chr. Inside the braces let us load the sbuff register, that is a serial buffer register, with the parameter we are passing on. So the parameter we are going to send is a single byte that is given to the sbuff, and let us wait for the transmit interrupt flag to change, set. When the transmit interrupt flag is set, that means the transmission is over, single byte is transmitted. After this, we'll reset the flag, that is the TI flag, to 0, so that it can send the second character. So to send a complete string, we use this send underscore str, which takes the unsigned char pointer variable str. Inside this function, we call the send underscore char. So even if you are giving a string, we'll send byte by byte only. We use the function while, and we wait till the null character. So we'll send one by one string, and inside this we'll increment the numbers one by one, so that all characters are sent. So in send underscore str, we use the send underscore char to send byte by byte. And next is the send SMS function. Inside this function, first we'll set the text mode to GSM by using the command at plus cmgf equal to 1. And after this, we need a 0x0d for carriage return. And the next function is send underscore str at plus cmgs equal to, inside the double quotes we have to send the number. So for sending double quote, we use the ASCII 0x22. So first we will send at plus cmgs equal to, and after that, to start the double quotes, we send 0x22, and then we use the send underscore str to provide the number to which the SMS is to be sent. This is the pointer variable. We have stored the number to send SMS. So first at plus cmgs, and then double quotes start, and then the number to send, and we have to close the double quotes. Again, we have to send the ASCII 0x22, and finally 0x0d for carriage return, and then a delay. Slightly long delay we require, 1 second. Next, we have to provide the message to send using the send underscore str, and within double quotes we provide the message to be sent to the number. And finally, we have to send the control plus z. So for this is very important. For this we use the ASCII 0x1a. So this 0x1a will send control z. As soon as the control z is sent, the message will be automatically sent to the number, and then a delay is required. So the code is completed now. So the code will start from void main. First we will call the UART underscore init to initialize the serial port of 8051. After serial port initialization, we will initialize GSM using the code GSM underscore init. We just set the baud rate under this GSM init, and finally we call the send SMS function. Inside the send SMS function, we use the send underscore str and the send underscore chr functions to send AT commands, to set it to text mode and send the AT commands. Now let us save this and then build the project. It is showing some errors. The errors will be displayed at the bottom. Let us go to the line number. The line number will be displayed. So go to that line number. Here we have misspelled, that is send underscore char. Let us correct it. And the next one is this semicolon is missing here. So go to that correct line number and then correct it. Third one, after this delay we have used colon, it should be a semicolon. Change it, save this, and then rebuild. Now you get 0 errors, 0 warnings. Now the hex file is created inside the project folder. Now open the prog.isp software, click on file, load flash, and then go to the objects folder of your project folder and select the hex file and click on auto. Now the ProgISP software will load the hex file onto the 89S52 IC. The green bar at the bottom of the ProgISP indicates the process. Once it shows ready, it means the hex code has been uploaded. Now once the code has been uploaded, let us wait for the SMS. Now you're getting the SMS on your phone number that is given in the code. So if you want to send it again, press the reset switch. The SMS will be sent again. As we are not using the while loop in the code, we have to press the reset. The SMS will be sent only once. To understand the code clearly, let us do the debug. Start debug and then start debug session, and click on view and then click serial window and then select the UART1. View serial window UART1. So at the bottom you will see the UART1 window, and next from peripheral select the serial channel. So serial channel, a separate window will open, and again from peripheral select the timer 1. So this two separate windows, you just align it, and we'll use the step function to check the code one by one. Step, either you press F11 or the step icon on the top. So when you press the step icon, it will start from the void main, and it will go, first call is to void UART underscore init. So under this void UART underscore init, SCON is set to 0x50. Watch the serial channel. Once the command is executed, the register value will change to 0x50. Next is the tmod. Watch it under the timer window. The tmod is set to 0x20 once the command is set. Next, th1 is loaded with 0xfd. Use the step command. When the command is executed, the th1 is loaded with 0xfd, and then the tr1. When tr1 timer is set, you can see the baud rate has changed to 9600 under the serial channel. Next is the call for the GSM underscore init. We'll use step F11, and the code will, when the code will go to while, it will hang on there, and so we'll use the step out function. At the top near the step icon, there is a step out. Click on the step out so that the delay is bypassed, and finally you get the commands in the UART window. First is the AT0, next is the AT plus IPR, that is the 9600, and finally the message to send, that will be displayed. So this is how the code works. This is the debug window of Kale Microvision. Thank you for watching.